discussing Tesla's Investor Day took place on March 1st, 2023. We are incredibly happy about this Investor Day because it really encompasses all the important factors that we identified in the prelude to the Investor Day in terms of what we would like to hear from Tesla and how we think Tesla should position itself for the future. And like I said in previous podcasts, as an investor, when you're in tune with the company, when they're able to finish your sentences in a sense that they're really doing what you think they should be doing, that's a very good sign for an investor, and that justifies our large position. Doesn't mean the risk is not there. The risk is still here, but nevertheless, we're very happy about this situation. So there's a couple of points we want to discuss. I think let's start with the problem statement. Drew Baglino formulated the problem statement, which is 80% of global energy comes from fossil fuels, and 1/3 of that is only used for work and heat. The rest is wasted. So the problem statement in Tesla's new kind of reformulation of the mission, or in other words, they're putting more meat around the bone what they actually mean when they say we're looking to accelerate the advent of sustainable energy. What they're really saying here is that there is way too much waste, that energy, the way it's produced right now, is not sustainable, and that we have to find better ways. And the solution is electrification. And the reason electrification is a good thing is because you can take renewable energy, turn it into electrons, and then use it in a flexible and much more sustainable way wherever you need it. This is the problem statement and the suggested solution. I'm going to go through the points of how Tesla wants to achieve this. There were two sort of parts of this Investor Day. One was the sort of global master plan 3 formulation of the problem statement, and then there were more specific Tesla specific ways suggested of how they're going to actually solve the problem in the two big vectors where they're going to be where their action is, which is the EV space and the utility space through storage. So I think the big takeaways for us, besides of all the positive stuff, the two big messages that came through here. One is that they're gonna innovate around the powertrain and the drive unit, and they're gonna try to find ways, and they actually put that slide down, that they're gonna make a drive unit without rare earth metals, and that's a huge deal. That is a huge deal. Not just because it's great to not have the environmental impact of rare earth metals, but also it means that there is a road towards a lot more innovation on the drive unit. And that was one of the vectors that we identified in the prelude. There hasn't been that much talk about drive unit and powertrain, and I think we should talk more about this. There are scientific breakthroughs that could change the game there, such as high temperature superconductors. But there's also, there's the other avenue which I think Tesla is taking, and that is to use reinforcement learning and AI and simulations towards a better way to combine the rotor and the stator, and to put the right pieces at the right three-dimensional space coordination, and then achieve maybe the same effects like permanent magnets would have that contain rarer metals. This is still an open question. They didn't discuss more of it, and unfortunately, because this was an Investor Day and not an engineering day, the question and answer session at the end of the event was relatively weak, coming from Wall Street analysts. That was expected, and we said just as a tangent, unfortunately, Tesla called this an Investor Day, and names define the rules of engagement. So in this case, the Investor Day was really an Investor Day, and therefore you got a relatively weak audience consisting of Wall Street analysts. Nevertheless, I think these are open questions we can keep discussing. So one of the big takeaways, again, no rare earth metals in the drive unit. What does that mean? How is this going to be achieved? And what are the avenues of further progress? I think the second big takeaway is that Tesla is doing exactly what we hoped they would be doing, which is in pushing the concept of vertical integration and lower cost of ownership. And that is the mantra of the company. And this might sound obvious, but it's not so obvious. And I think Zachary Kirkhorn reinforced this. It came across every presentation: vertical integration, building out the supply chain, across the supply chain, across the value chain. Those are very important factors when you're building such a massive scale operation, and when your goals are so big, you have to build the supply chain from scratch, and that's exactly what they're doing in many ways, and they've communicated this. And I think for us investors, it's important to be in line with that kind of mission, because how else could we justify the massive value creation that we expect? So this is Not in Wrong podcast. It's March 4th, 2023. This is Krim Delco. Today's a Saturday. There's no update. We are up 63.1% for the year. The market's up 57.3%. We're outperforming by 56.8%. The problem statement of Master Plan 3 at Tesla is that 80% of the global energy is produced with fossil fuels, and only 1/3 of that does work or heat. Therefore, there's lots of waste, and Tesla wants to accelerate the advent of sustainable energy in a sense that they want to help replace the energy infrastructure towards electricity and therefore increase the efficiency. So according to Tesla, they can go from 165 petawatt hours per year to 86 petawatt hours per year of produced energy, because the electric version of energy is a lot more efficient. There's a lot more less waste, and so on and so forth. So this is the problem statement. And the way Tesla wants to solve this problem is by changing the energy infrastructure on the utility side and changing the energy infrastructure on the EV side, which according to Tesla is about 60% of the global energy. There's also things like heat pumps and airplanes and boats and other things that they mentioned in the plan that need to be decarbonized. But that is, at this point, that is not so relevant. Let's talk about what Tesla is actually, sort of the vectors where Tesla has influence, and those are the utility side and the car side. So let's start with the car side. The car is a data center on wheels. So what Tesla is doing on the electronic and powertrain side was one of the most important messages in this call. We stated that also in the prelude, because we believe that in the end, it is a product that people buy for certain things like performance and so on and so forth. But what's more important here is that Tesla is really changing the game as far as digitization is concerned. And Volkswagen CEO Herbert Diess actually said that a while ago, that the ability to have software control the car and have a centralized system, and also according to David Lau, which is the software lead at Tesla, the ability to learn from data and change features in the car. So that whole equation is only getting more and more developed at Tesla, and we believe that this is a source of competitive advantage, because it's going to increase the value of the car to the people who buy it. And it's not just AI, by the way. That's a different topic. This is what we call the operating system of the car. So the car is Tesla is a transportation company where they sell robots on wheels to people. But the way Tesla thinks about this is that the car is a robot on wheels. So you have sensors which are connected through controllers, which those controllers are connected through Ethernet in the car, and then there is a connection from the car to the data center. And David Lau said that the way Tesla thinks about this is fully integrated from the data center to the wheel and back. So this is certainly a very encouraging and important part of the equation. Pete Bannon is the other lead here. He is the electronics lead, so he was the one who designed the inference chip at the car. So he clearly has expertise in designing controllers, or in other words, low power, high performance chips for embedded systems. That's his expertise. And that is, of course, where we believe the future, not just of Tesla, but of software development, or certainly one of the important futures is to have a lot more software in hardware and to have software-defined hardware. And this is very encouraging for us. One of the questions we have for Tesla here is, well, why not build an app store for Tesla features? So, for example, they mentioned one feature where you have an automatic adjustment of suspension based on the road conditions, which are derived from telemetric data that the Tesla fleet delivers to the company. In other words, they can predict. So the California street on in San Francisco between Steiner and Fillmore is a little bumpy. So why don't you adjust your suspension? That kind of stuff. Tesla is doing that, but what if we had third-party apps developing apps on top of the Tesla platform? That will be incredibly useful. So again, software-defined hardware. This is really a big deal. We believe that this is a vector of innovation that will pay lots of dividend for us shareholders and, of course, for customers. I think the other big takeaway we got from the Investor Day was the drivetrain unit. Colin Campbell, the head of drivetrain and powertrain and drive unit, and that part of the business. What's important here is, I think, the statement that they want to go permanent magnet without rare earth materials. Rare earth materials are necessary to improve the magnetism of the permanent magnet, to improve heat resistancy of power control systems, and just in general increase performance, reduce weight, things along those lines. And if you can do a permanent magnet without rare earth, to me, that is a big statement. It's not just because of the environmental impact that is going to be reduced, but it's really also interesting what kind of technologies they will develop to get to that point. And I believe that the upside here is that you could have either, or probably the solution is kind of a little bit like DeepMind using reinforcement to contain the nuclear fusion reactor. It has to be a sort of reinforcement / AI type system that learns how to combine the stator and the rotor and how to put the materials together in a way where you can have the same performance like a strong permanent magnet in a drive unit without having rare earth metals. So the one is AI could be useful here, and the other is, of course, simulation or all of the above. And actually, Colin mentioned simulation as being a key component of the Tesla drive unit development. Those are things that are not being talked about enough, because we have lots and lots of vectors of innovation here. Why? Because imagine if we had better conducting materials, superconducting materials, those sort of things, how that could improve the amount of just performance, lower weight, lower cost, all those things. But I think this is a very nice example of, you see, once you open it, this is very Popperian. Once you start solving the problem of getting rid of rare earths, you're putting a constraint on yourself and then solving that, and then the solution becomes, or that constraint then turns into a solution, and the solution could open up many doors, many interesting doors for new developments, and take us on a road of innovation and development that could end up in much more efficient and much more interesting ways to harness energy that we don't even know about today. So we're very excited about those two things: the software-defined hardware and the ability to build drive units and powertrains without rare earths. Those are very important vectors of innovation. I want to talk a little bit now about the concept of building a supply chain from scratch and building a supply chain across the value chain. This was actually emphasized also by the people who are actually in charge of supply chain. And they spoke about how Tesla is not just doing a lot of stuff themselves, but also working with tier 2 suppliers in particular to reduce complexity and and make sure that the supply of components is there for the kind of growth that Tesla is expecting. And this is very, very important. People always look at growth rates and they think, well, this is possible, this is not possible. But the way you should think about growth, a company like Tesla, is not just what's the demand for cars. It's also what can they produce, and they can produce based on the components. And what the supply chain people said is a component for Tesla is a chain of tier 1, 2, 3 to X type of suppliers who built that component. So once it comes to Tesla, many other people have touched that component. And sometimes Tesla chooses to actually produce the component themselves, and most of the times they don't because they can't and it's not feasible. There's expertise elsewhere. But Tesla engineers, when they design a car, when they design, let's say, next generation, the Generation 3 platform, they're thinking about those things in terms of how it can be built, how it can be built at scale, how, not just the components, but then how can they be integrated into the car. So this vertical integration is absolutely key, and it came across in many presentations throughout the call and the Q&A also. For example, now let's talk about the charging infrastructure, another vector of innovation. The important thing about the charging infrastructure, of course, the head there, Rebecca Tinucci, is that charging is an absolutely necessary component of the success of Tesla. And what Rebecca was emphasizing again is the low-cost at-scale installation and production of these things, because you can't grow a fleet by 50% every year without having the charge network support that kind of growth. So very encouraging here. And I think this is a good bridge now to the utility side of things. And the way I see Tesla there, it's you're connecting renewable produced electricity with the use. And within the car space, that means that you're producing electricity with wind and solar, and then you have to bring that electricity to the car. Rebecca's part of that, of course, is to make sure that the charging stations are spread in a way that they're useful to people when they need it and where they need it. So for that, they have, of course, a supercharging network where trip planner is a big component of making sure that people go to the right place at the right time. The more you use a supercharging network, the lower the cost per kilowatt hour of charging, but then you also want to make sure that the experience is still good. So that's sort of the optimization space that Rebecca is dealing with. And then you can add to that concept of what Drew Baglino said, which is that, well, we're not just trying to build efficient superchargers. We want to replace the current fossil fuel-based energy infrastructure with renewables. And the way we can do that is by building low-cost storage. It's storage plus power electronics, which will solve that problem. Why? Because when you have a solution, when you have production with renewable energy, you have the electrons, but you have them in places and at times that might not be convenient for the usage. To bridge that gap, you need storage and power electronics. So I think this is, again, one of those obvious things that, in my point of view, is an absolutely important granular understanding of the utility business of Tesla, and incredibly exciting. So bring electrons to where they're needed and when they're needed, and make sure they're produced by renewable energy. I can't emphasize this enough, and this is the key to the solution to the problem of how we can electrify, how can we electrify the energy infrastructure going forward. So to summarize, I think this Investor Day was very, very useful. It was along the lines of the Battery Day. I would say it's the next level of granularity and excitement, and also directionally showing where Tesla is going. It's hopefully inspiring people to go study these things at the university level, which is one of the questions, of course, that I always have for Tesla. How do you deal with the sort of legacy academic production of human capital, and how do you translate that into this very exciting form of work that you have at Tesla? Is that a problem? How do you deal with that? Those would be very interesting questions to discuss. I think another question we have is, why is Moore's law not penetrating faster into the sort of car space? And I think the solution is one of the biggest takeaways here, which is software-defined hardware through power electronics, and creating basically robots on wheels integrating all the way to the data center. All of these things will help bring Moore's law closer to the electric car industry and also to the power industry, which is, like we said, going to be solved through storage and power electronics. We think that Tesla is doing the right things, at least from our perspectives. They're vertically integrating as much as they can. Their focus is on lowering the total cost of ownership by increasing quality. They can do that by applying software, vertical integration, integrated engineering, and also by tackling difficult problems through engineering and sometimes even through science. And one of them, the best example, is the rare earth metal problem in the drive unit. You have a permanent magnet, you still use a permanent magnet, but you're not using rare earths, and that is opening up many, many avenues of research. And this is the key, the avenues of research, which will then create new innovation paths on which Tesla can go and create things that we don't even know about today. Finally, I just want to say there was also Ashok was there from the AI team, and we're not discussing this particular area because it's in its own so important that that we don't want to touch on that here. We've spoken about this many times before, but it's certainly also part of the story. It's not like we neglect this, but I think this Investor Day was more about everything else, about Master Plan 3, which is decarbonize the global energy infrastructure by electrifying it. And the way you do that is by building low-cost storage, which is you innovate on the battery front, and then you innovate on the software front, where you try to have as much software-defined hardware as you can possibly do. And this is, of course, a moving target, and the more time you have, the better you're going to get at it. But Tesla is on that path. This is the key. I think finally, I also want to say just one thing from an investor's perspective. I think what Tesla did in Master Plan 3 is actually send out a message, which is, so far we've been so ahead of competition with having many of those things not fully in place, software-defined hardware, the energy density of batteries. All of these things are still relatively not low-hanging fruits, but we can improve a lot more, and that means that we're going to actually have a much faster pace of innovation and differentiate ourselves even more from competition. In other words, we're going to have much higher market share. We expect Tesla to end up with a maybe 25% market share in the transportation market / car market in the next 5 to 7 years. That means others will have space, but Tesla will have a very large market share, sort of along the lines of the Apple market share in the iPhone. And then on the utility side, the same thing here. The market share here is very high because nobody is even close to having the kind of energy density and the software-defined system that the Megapack and the solutions that they provide consist. So all of these vectors will drive the innovation path for Tesla and differentiate Tesla more and create value for customers and shareholders. Thank you.